Good morning, good afternoon, and good evening, everyone, and welcome to this Inside Scientific webinar entitled The ANY-maze Operant Interface, Running Operant Experiments Using Anymaze. My name is Darius Sulam from the events team here at Scientist.com, and I'll be your host today. This webinar has been sponsored by Stoelting Co., so a big thanks to them for helping make this event possible. Our speakers today are Dr. Trent Lund, President of Stoelting Co., and Dr. Flavia Teixeira Silva, Anymaze Scientific Advisor at Stoelting. In just a few moments, Trent and Flavia together will be giving you an overview of the Anymaze Operant Interface, demonstrating its capabilities for behavioral experiments. And now with that, I'd like to welcome our presenters, Trent and Flavia. Thank you so much, you guys, for being here, and take it away whenever you're ready.
Thank you. Today we're here to introduce you to the Anymaze Operant Interface, which has been designed to make it simple and straightforward to automate operant experiments using the Anymaze software.
You've probably already heard of Anymaze as a video tracking system, which is widely used to automate tests such as the plus maze, the open field, the water maze. So you're probably wondering why you would want to use Anymaze to perform operant experiments. That's right, Anymaze was developed 20 years ago as a video tracking system, but since then it has developed into a broad platform that can be used to automate all sorts of behavioral tests, including ones that do not use video tracking at all.
Yes, as to why you'd want to use Anymaze to run operant experiments, well, that's the question we're going to try to answer today in today's webinar. By the end, we hope you understand its benefits and see how Anymaze stacks up against the software you're currently using.
So in the next 45 minutes, we are going to show you how to connect your cages to the interface and configure it so Anymaze knows what's connected to. Then we are going to set up a real-world experiment, run some tests, and analyze the results.
Great. As Flavia just said, we'll start by taking a look at that interface. And here it is. For those of you who have MetaSociates, you may find this to be quite familiar. This was designed to be a drop-in replacement for the existing MetaSociates box. One major difference is that the interface will connect directly to the computer via USB, no other cabling. However, while it is connected via USB, it's not powered through the USB. And for that, you'll need either a simple power brick, or you could use the operant USB hub that we have, which will allow you to connect up to 4 boxes. Now, MetaSociates aren't the only company who make operant conditioning equipment. For others, such as Lafayette, we have also designed an interface. This again is just a drop-in replacement for the existing Lafayette equipment. It will again require a USB simply back to the computer and some sort of power, either the hub or a power brick. We're also currently working on an interface for Colburn instruments, which will again connect right back to the computer via USB, simply using the power. All right. All 3 of these devices will be set up the same way within Anymaze. Although we'll be focusing solely on MetaSociates here, know that Colburn and Lafayette instruments will be configured the same way within the software. Okay, now let's talk about converting the MetaSociates box using the Anymaze Operant Interface. The first step is going to be to remove the connectors. Before doing so, it's a good idea to mark your outputs and inputs. You'll see why that's important a little later. Once your connectors are disconnected, you can remove the old box and replace it with the Anymaze interface. At this point, it's a good idea to make note of your components. In my case, I have a house light, 2 retractable levers, 2 stimulus lights, and a tone generator. Most manufacturers include part numbers on their components, and it will simplify things later if you note these 2. Now we're just going to connect the components. In this, we're going to make sure that our inputs are plugged into inputs and outputs are plugged into outputs. This is why we mark those connectors ahead of time, to make sure that outputs are going where they need to be. Now, it's not really important which output gets plugged into which connector. However, once you choose which connector to plug into, you're going to want to mark that and indicate so you know that for configuration within the software. Once we have all those connectors connected. We're now going to power this up. We'll do so by connecting the power. We find that there is a red light. That means that the power is connected. And now we just need to connect it to our computer. In doing so, we'll turn our light green. And we're ready for use. That's it. And that's how we physically set up a single cage. Now, chances are you're going to use multiple cages, and you'll find that you'll set those up exactly the same way. What you want to do is note the connections for your first cage, and then set up all the other cages exactly the same way. We'll find out why that's important a little later. If you're using Lafayette or Colborne setup, you're going to find that the components connect exactly the same way. It's the same connectors that you're using now, and so you'll just connect your components the same way. And that's it. That's the physical setup of our box. We'll now turn the time back over to Flavia, who will show you how to configure those components for use within Anymaze.
Thank you, Trent. So now that we've connected the interface to a cage and to the PC, it's time to configure it and test it within Anymaze. I'll come back later on and explain a bit more about the general structure of the software, but for now we are just going to use the I/O page, which we can access by clicking that I/O tab up there. You see, Anymaze has already detected that there are cages connected to the computer, and it's listing them here on the left. If we click on the first one, we can see a list of items which it connects to. At the moment, we only have one input switch, which is actually the test control button. This is the red button that is at the top of the interface, and it's used to start tests in the cage. Now we're just going to use it to test to see if everything is working. So if Trent presses the button for me, yeah, we can see that Anymaze is detecting the presses. So, of course, our cage is connected to a lot more components, but Anymaze doesn't know about them yet because we haven't configured the cage yet. So that's what we're going to do now by clicking this configure button up here. As we can see, the configuration window is split into two parts. The top part has information about the cage, and the bottom part is actually the part we are interested in, because that's where we're going to tell Anymaze about the components that are connected to our interface. So let's add a component. This list contains all 180 Med-associated components which are compatible with Anymaze, and they are organized by type. And of course, if you're using a Colborne or a Lafayette interface, then you're going to see their components instead. Remember that Trent prepared a list earlier with all the components he connected to the interface. So let's take a look at his list, and we can see that the first component is a house light. So, and more specifically, a ENV215M. So let's select it and click Next. Now we have to tell Anymaze where it's connected, and according to Trent's list is output 1. Anymaze is suggesting that we give this component the name of house light, which we are happy with, so let's finish. That's it. Now our house light is in the list of components. Now let's add another component. Referring to Trent's list again, the next component is the left side retractable lever, more specifically a ENV112BM. We could just go and look for it in this list, but alternatively, we can just search for it. Yeah, there it is. This one has an input and an output. The input is the response of the lever, indicating when the animal presses the lever, and it's connected to input 1. And the output is operates the lever, extends it and retracts it, and it's connected to output 16 because Trent decided to connect it there. So next. And here it's a good idea to change the name because we actually have 2 levers and we need to know which is which. So let's call it left lever. That's it. Now we have 2 components in our list. and we need to do this for each of our components. But just for today, to save us time, we can employ a little magic. Ta-da! All our components have magically been added to this list, as you can see, and that's our cage configured. But what if you have lots of cages, let's say 20 or 30 cages? Doing this for each one of them would be tedious and time consuming. So that's why Trent suggested setting up all the cages in the same way, because now you can just copy this configuration to all other cages, or just select the ones that you want configured in the same way. And that's it. So now that our cages are configured, we can see that there is a much longer list of items inside the cage, and we can use this list to test everything. So we now also have input switches to the left lever, which Trent is pressing for us, and for the right lever. Are you pressing that, Trent?
Yep.
Okay, so it doesn't seem to be working, so let's check our configuration. Okay, Anymaze thinks that it's connected to input 4, but it's actually connected to input 2. So let's change that and test it again. Yay, it's working now. We also have output switches to control the levers, so we can extend them and retract them. And we have light controllers. For the stimulus lights, we can turn them on and off, and for the house light. Actually, Anymaze can control the intensity of any light connected to the interface, so we can make the house light brighter or less bright. Okay, once we've tested all of the components in cage 1, we can do the same for cage 2 and cage 3 and so on. Of course, you may sometimes want to change the components in your cage. If that's the case, you just go back to the configuration and edit it. And that's it. That's our cages configured and ready to be part of an experiment. But before I tell you how to set up an operant conditioning experiment, I'm going to give you a brief introduction to the software, to the general structure of the software. So you can see up here that Anymaze is divided into 5 principal pages, and so that you can understand what each one of these pages is for, I'm going to use an example experiment that comes with Anymaze. It's going to be a water maze experiment, which of course is not an operant conditioning experiment, but as a classic behavioral test, I'm sure you're familiar with it. The way to perform an experiment in Anymaze is by starting on the left of these pages and working your way through the right. So we start with the protocol page, and this is where we define what type of experiment we want to perform. So in the case of our water maze, we have defined our apparatus by drawing around it and dividing it up into different areas. We've also set up some zones of interests, so we have different quadrants, and of course the island that the animal needs to find. We've also added a procedure to tell Anymaze that the test should end when the animal finds the island. That's it. You can see that there are lots of other things that could be set up in this protocol page, but almost all of them are optional, and in one single protocol, you'll probably only use a few of them. So the next page is the experiment page, and here is where we define the specific experiment we are going to perform. So here we trained our animals to find the island, and then we injected them with either saline or one of 3 doses of compound X in order to see if compound X has an effect in their memory. The test page is where we actually perform the tests. Here on the left, we can see what Anymaze calls the test schedule report. And we can see that most tests have already been performed, but there are still some tests to run, which we could do by clicking the Start button up here. If we click on any test Anymaze gives us access to the test details report, which give us the results to that single test, and also give access to all related reports. While it's useful to take a look at a single test, what we really want to know is whether compound X had an effect on our animal's memory, and that's what the results page is for. Here we can analyze our results among groups, and we can see that the saline animals took around 10 seconds to find the island, while the animals which received the highest dose of compound X took around 80 seconds. Let's see these results as a graph. Well, it looks like compound X had an effect, but the error bars are quite big, so would that be statistically significant? The stats report shows it is. Anymaze has around 40 built-in stats tests, but you still might want to extract your data and analyze them in your favorite software, and that's what the data page is for. Here, Anymaze shows the results of all the tests in a spreadsheet format, which you can copy and paste into other programs, such as Excel and SPSS, or save it in a standard format, such as CSV. So this was our review of Anymaze. Hopefully now you understand the basic structure of the software. So now it's time to set up an operant conditioning experiment using it. So, we are going to use a very simple protocol using Trent's cage for that. And the basic idea is that we have a stimulus light that is going to change its state every 5 seconds. So 5 seconds on, 5 seconds off, 5 seconds on, 5 seconds off. If the animal presses the lever when the light is off, it will get a reward. If it presses the lever when the light is on, it should get a punishment. In real life, it would be a shocker. But as we are here and Trent is our animal, we are just gonna play a tone instead. And that's it. Let's keep it simple so that we can introduce some concepts. So let's create a new experiment. This will open on the protocol page because the protocol is the first thing we need to define. And I'm gonna call it simple operant example. The next thing we need to do is to set up our apparatus. So let's add an item to our protocol, which is actually our operant cages. We're going to add just 2 cages because we want to keep this simple. Our cages are already configured because we did that earlier. We could change the configuration at this point, but we're just going to keep it the same. So now we can see that Anymaze has added items to the protocol, which correspond to the components we have in our cages. So we have on-off inputs for the levers, output switches to extend the levers. We also have an item for the speaker, which I want to make a small change to, which is to say that when it plays, it should do so for only half a second. The next thing we're going to do is to set up the duration of the tests. And I'm going to make it only 30 seconds because this is just a demonstration. This leaves us with just one thing left to do, which is to actually tell Anymaze how we want this test to be performed. If you remember, we want the light to turn on and off every 5 seconds, and if the animal presses the lever when the light is off, it will receive a reward, and if it presses the lever when the light is on, we'll play a tone. To set this up, we need to use what Anymaze calls procedures. Procedures are essential to the use of Anymaze for operant conditioning because they are actually the things that control the experiment. So let's first sort out the light. For that, we are going to add a procedure to our protocol. And we're going to call it flash the light. Now we need to actually build this procedure, and we do that by simply dragging statements to the procedure pane like this. And the first thing we need to do is to wait for 5 seconds. Then we need to turn the light on. Then we wait for another 5 seconds. and we turn the light off. When all this is done, we want to repeat it again and again. And that's it. This procedure will make our light turn on and off every 5 seconds. Now we're going to add a second procedure to our protocol to tell Anymaze what to do when the lever is pressed. And we're going to call it process lever press. First, we need to do some administrative work because our levers are retractable. So before Trent can press the left lever, we need to extend it. Then we need to wait for the lever press. Now we can do one of two things depending on whether the light is on or off. If the light is on, then we'll play a tone. Remember that we set this up earlier, so the speaker is going to play for only half a second and turn itself off automatically. Then if the light is off, then we are going to give Trent a reward. After that, we're going to wait for the next lever press. And that's it. That's our second procedure complete. And actually, this is our whole protocol set up. We just need to add some animals to our experiment, which we do here on the experiment page. Let's say we have 6 saline animals and 6 drug animals. Now we are ready to run our tests. We can see here that on the left, Anymaze is already listing all the 12 tests that we have to perform, one for each one of our animals. And it's ready to perform a test on animal 1 in cage 1 and animal 2 in cage 2. When he's ready, Trent is gonna press the test control button at the top of the interface to start the test, and he will act as our animal by pressing the lever. This we will see here on what's called the I/O status panel. And the test has just started, and Trent just pressed the lever when the light was off, so he got a reward. Now he pressed it again when the light was on, and we played a tone. And we can see that this is continuing to happen. So maybe Trent is learning how to press the lever when the light is off. Actually, there is something else that we can add to our protocol to help us visualize what's going on during a test, and that's a chart. So let's add one now. First, we'll add a chart to indicate the lever presses. Then we'll add a state channel to show us the state of the light. Then we add another chart to indicate when we give a reward, and another one to show us when we play a tone. All this is going to make more sense when we run another test. But before we do that, let's first disable cage 2, because we're not using it anyway, and this will make the charts clearer. Now it's much easier to visualize Trent's performance in the test. The green background indicates when the light is on, so it's easy to differentiate between lever presses that happen when the light is on versus when the light is off. By the way, we can view this chart when the test is running, so live as we are doing here, but we can also see it after the test is completed. So that's all we're going to do with this simple experiment. It was never intended to be of any real use. We were just using it to show you some important things. So first, Anymaze populates the protocol with relevant items according to your cage's configuration. Second is that we can use multiple procedures in order to control the equipment and the response to events, such as lever presses. And finally, we can get feedback during the tests by using the I/O status and charts panels. That's it. Now that I've introduced everything, it's time to take a look at a real-world experiment. So the basic design I took from my study published in 2015 by Martin and Iceberg. It was published in Jove, and it's called Quantifying Social Motivation in Mice Using Operant Conditioning. So in this study, the authors had in the cage 2 levers, one that when pressed would deliver a food reward via pellet dispenser, and another one when pressed would lift up a guillotine door, exposing behind a grid another animal, so offering a social reward. To start with, in order to get either reward, the animals had to press the lever 3 times. But after that, the required number of presses kept increasing. So in order to get a second reward, the animal had to press the lever 6 times, and to get another reward 9 times. So the cost of the reward kept increasing by 3 each time. If the animal stopped pressing the lever for 5 minutes, then the test would end. And the key result that the authors were looking for was the maximum number of presses that the animal was prepared to make in order to get each one of the rewards. So let's set this up in a new experiment. First, we are going to name our protocol Social Motivation. Then we are going to add some cages, as we did before. In this study, the investigators used as maximum test duration 60 minutes. So that's what we are going to set up. And now we just need to add some procedures. The first one is a very simple one, just to count the number of lever presses that the animal makes. But before I build this procedure, I need to introduce you to a new feature called variables. So variables here have nothing to do with the independent and dependent variables that we are so used to. This is a term that comes from the programming world, and it simply means something that can record a value. And we give the variable a name which identifies whatever it is recording. It's going to be a lot simpler when we start using it. So let's use a variable to record the number of presses that an animal does. Let's create one and call it press count. And for reasons that will be clear later, we are going to say that this variable is going to be used by all procedures in the experiment. So now let's build our procedure. First, we need to wait until the left lever is pressed. Then, when that happens, we need to add 1 to our press count. And we'll keep doing this forever. So every lever press increases the press count. And that's all this procedure has to do. Next, we are going to add another procedure to actually give the animal a reward when it presses the left lever an appropriate number of times. Like we did in the example experiment earlier, the first thing this procedure will have to do is to extend the lever so the animal can press it. Next, we are going to add a variable which we are going to use to keep track of the number of presses an animal needs to make in order to get a reward, and we are going to call it required number of presses. This variable should start off with a value of 3 because that's the required number of presses for the first reward. We'll now wait until that number of presses occurs. And remember, the other procedure is counting up the presses. So here we can wait until the press count variable is equal to the required number of presses. This is why the press count variable needed to be available to all procedures. When the animal has pressed the required number of times, we're going to give it a reward. And then we are going to increase the number of required presses by 3. Then we'll set the press count back to 0, so it starts counting to the required number of presses again. And then we'll keep repeating this sequence. If you remember, the main result that the investigators wanted from this experiment was the maximum number of presses that the animal was prepared to make in order to get a reward. In order to report this, I'm going to make a small change to this procedure. So first, I'm going to create a variable called max presses to gain food reward. And I'm going to say that this variable should be reported as a result. And then I'm going to set this variable to however many presses the animal made to gain a reward. As we'll see later, a result for max presses to gain food reward will now be available for all tests we perform. Now that the process of the food reward is all done, we could go on and create almost identical procedures to count right lever presses and to give the social reward. But as we don't have enough time now, I'll just employ a little magic and all the procedures are going to be added instantly. Voila! In fact, this has also added a procedure to end the test after 5 minutes with no lever presses, and another one to show us how the test is progressing. And that's the protocol completed. By the way, something I haven't mentioned before is that you can save a protocol like this. So you can use it in other experiments. You don't have to rewrite the procedures every time. So now let's add animals to our experiment. So let's say that again, we're going to have 6 saline animals and 6 drug animals. Now Trent can run a test. As you can see, he's pressing the lever and he's being rewarded with food pellets. By the way, the messages being shown in the messages panel is being generated by that procedure I mentioned, which shows the test progress. Now he seems to have stopped pressing, and in the real-world experiment, the test should end after 5 minutes, but I set this up to end after 5 seconds, so the test has ended already. Let's look at the results of the test. Here we can see that Trent pressed the food lever 9 times before he decided that the cost of a food pellet was too high. And he didn't press the social lever at all. Of course, we have only run one test, but with a little bit more magic, we can just run all the tests in our experiment. And now we can look on the results page to analyze the differences between our groups. And we can see that our drug animals were prepared to pay significantly more for a social reward than our control animals. Finally, there are a couple of additional things I would like to mention about this experiment. First, the authors obviously trained the animals before testing them, and this is something that you can easily set up in Anymaze. So you can just add an additional stage, a training stage, and then you have your testing stage. Actually, the animals were trained to a criteria, so they had to press the lever at least 10 times in 3 out of 5 consecutive trials, and this is again something that you can easily define in Anymaze. So the software automatically detects the animals that have reached criteria and therefore don't need any more training. Also, the authors assessed locomotor activity through photo beams. Anymaze could use photo beams, but alternatively, you could use video tracking. video tracking is really easy to set up in an operant conditioning experiment. You can use the information not just to assess locomotor activity, but also within procedures, as you can, for example, make a light turn on if the animal access a certain part of the cage.
Of course, if you're going to use video tracking, you're going to need to fit a camera to your system. And for that, we've designed a camera mount that can be easily removed and mounted back onto that cage.
We are reaching the end of this webinar, so let's summarize the key points that we've covered. So the Anymaze Operant Interface family was specifically designed to help you connect equipment from Med Associates, Lafayette Instruments, Colburn Instruments to Anymaze. The Anymaze user-friendly configuration makes it easy for you to define what components you have and where they are connected. With Anymaze, it's easy to build a protocol. It's very straightforward, as you can interact directly with your left lever or with your food dispenser without having to think about connections or ports or states. And finally, Anymaze's powerful procedures allow you to build sophisticated protocols in a simple and understandable way. So that's it. We hope now that you understand what the interface does and the benefits of using it to perform operant conditioning experiments using Anymaze.
Before we go, there's a couple of things I'd like to mention. One, Anymaze comes with free lifetime technical support. And two, all updates are provided for free forever. I hope you've enjoyed the webinar. We hope to see you again soon. Bye for now.
Bye.
We'll pass things back to Darius.
Awesome. Thank you so much, Trent. The thanks go out to both of you and Flavia, for sharing Anymaze with us today and all of its features and capabilities for research. It's been a pleasure having you both with us. A big thanks to you, the audience, for joining us today, and our friends at Stoelting, this event's sponsor. In closing, we hope you enjoyed this Inside Scientific webinar, and we'll see you again next time.